times height times gravity divided by A. A cancels out, and we get that the gauge pressure is rho g h, where h is the altitude from the bottom or depth from the top, the way you want to call it. Altitude from the bottom or depth from the top. Either way is the same h. So between 2 points, if I want to find what will be the gauge pressure between 2 points, the gauge pressure, which by definition is the pressure between 2 points, will be rho gh. At this point, what will be the absolute pressure? The definition of gauge pressure is the difference in pressure between 2 points. This is the actual definition of gauge pressure. What will be the pressure absolute at this point? Will be the external pressure, which in this case is the atmospheric pressure. What is atmospheric pressure? The pressure that the atmosphere is exerting on the Earth's surface. This is the definition of atmospheric pressure, which is the weight of the atmosphere over a certain area in average. Because the atmospheres we have here, and the clouds and everything, that exert the pressure over the Earth's surface. This is an atmospheric pressure, which is equal to 1 atm. So, because at this point, imagine that we want to find the pressure between these 2 points, this point and this point. So what will be the pressure here? The external, because as Pascal said, is the external pressure plus the pressure due to the depth, which I will call plus rho. Let's say that this is H1 or H2 and this is H1. So will be external pressure plus rho GH2 minus, what will be the pressure at 1? The external pressure plus rho GH1. P external cancels out, and what we get for gauge pressure when the fluid is at rest? Rho G delta H. This is the definition of gauge pressure. So, summarizing, what is Pascal principle? Said that when the fluid is at rest, the pressure absolute will be the summation of the external pressure plus rho GH, which is the gauge pressure. This is the Pascal principle, which is the first case, the main point on the first case. The P absolute is the P external plus rho GH. If this is the fluid, if this is the container, and it's open to the atmosphere, what will be the external pressure? Let's say, on this amount of water that I have here, okay, so if I put water here, so you can see that the water is going out. So what will be the external pressure here? 1 atmosphere, 1 atm. So anytime that you have a container open, what I call external pressure is the pressure of the atmosphere, which is atmospheric pressure, 1 atm. Okay, this is 1 atm plus rho GH. So if you are on the bottom of the ocean, what will be the absolute pressure 100 meters below the surface? Will be the external pressure, 1 atm, plus rho GH. What is the density of water? 1,000. Because we have gravity, what did I say? Whenever you have gravity in the formula, what unit you have to use for density? The kilogram. So it has to be 1,000. Remember that. And you cannot add ATM to Pascal. You have to convert which one? Pascal to ATM or ATM to Pascal? Which one is the international? Pascal. So which one you have to convert? ATM to Pascal. Got it? And the density is always 1,000. Okay, Pascal principle. Let me just go over an example on Pascal principle. Let's say, and this is one of the applications of the Pascal principle. Let's say that we have a U-tube, which is basically the working principle of the barometer. Barometer is the instrument to measure pressure. So let's say that we have a U-tube, and we have here oil, and we have here water. Because the oil is less dense than the water, it will push to a certain level. So this will be below that level. Let's say, for instance, that I give this distance, which I will call the height of oil. This is the working principle of the barometer. You know, sometimes you heard another unit for pressure, which is the height in the column of mercury. How much is the atmospheric pressure using the height in the column of mercury? Have you heard that unit? 760, right, millimeter in the column of